So Thomas is studying the relationship between temperature and hours of sunshine in CPROM. He records the midday temperature T Celsius degrees and the hours of sunshine S for random sample of 9 days. So N is 9, yeah? He calculated the following statistics. So he's got the sum of S, S squared and T, and he's also got, I cannot read my own handwriting. I think that's STT. Okay? Calculate SSS. Alright, so this is standard formulas. So this is the sum of S squared minus sum of S all squared, so 15 squared over 9. Plug this in and you should get 19.22. Okay? Next one. So Thomas calculated the product moment correlation coefficient between S and T and found out that the value was this. So this is the R value between S and T being 0.832. Okay? Now state, giving a reason whether or not this correlation coefficient supports the use of a linear regression model. Now before I even read the rest of this, if your R value is close to 1, or if it's negative, if it's close to -1, if you can get a negative or positive correlation, then the answer would be yes, it supports a linear model. Because a linear model, all it simply means that we want to make a line of best fit between our data points. If we can do that, then it supports a linear regression model. Okay, and then yeah, so to describe the relationship between midday temperature and hours of sunshine. So I just wrote yes, the R value is close to 1. So we can assume a linear model to represent a positive correlation between midday temperature and hours of sunshine. I would probably check the masking for any additional information on this, but I think that should be okay. Now C, state giving a reason why the hours of sunshine would be the explanatory variable. So in this case, it's usually explanatory variable is always the X term. It's always the X value in the Y equals A plus BX model. It's always the value that for one variable to depend on another. Okay, between midday and sunshine. So what this means is that S is the explanatory variable, so instead of X we can put S there, so it'll be A plus BS must equal T. Reason why we say this is because the hours of sunshine, the midday temperature always depends on the number of hours of sunshine and not the other way around. That's kind of why they suggest it. If you didn't know, you would always just say because T depends on S or Y depends on X. This is just the standard way, but always the temperature in this case will have to depend on how the hours of sunshine are moving. Okay. Anyway, I hope that helps. Let's move to part D. If you need more explanation, just let me know, and then I'll try to do my best to leave a comment on that. Okay. Yeah. So 5. So now on part D and E. So we're gonna do D and E here. So find SST. Okay. So same thing applies. Oh, actually, for this one we couldn't use the general formula. Reason why is because we don't have all the necessary variables. We don't have the sum of ST. So what I did here to calculate this, I just used the relationship between the correlation value R with the general between S and T. So SST over the general formula. Then I just substitute all my values I knew. We have SSS, we plug it there. We have STT from the previous question, which I did not put down, but it's here. And we have the correlation from part B. So yeah, 0.832. So we plug over there. Then you just make SST the subject and you should get 12.04. Okay. Okay, so let's see. Alright, so that's done. Now calculate a suitable linear regression equation to model the relationship between midday temperature T and hours of sunshine S. So we're using the equation from the earlier parts. Now this is just standard procedure. We just need to find the values of A and B. So A is the mean of T minus B times the mean of S, whereas B would be the S between ST, so SST over SSS. So just if you're unsure what to use, when it comes to the second part, the below part, just recall that the second half must always be the explanatory part. So it's always the X one. So because X is basically S, just put that down. Now divide these two with the values you know, you get 0.626. T bar and S bar is just the mean of T. So the mean of T is 100 is the sum of T over N, which is here, and S bar is the sum of S over N, which is there. And then you just use it with your B value from here, and you should get A equals 13.1. And then plug into your equation. Try to keep the 3 significant figures, yeah? Oh, this is coming off the page, isn't it? Alright, so let me just go back a bit. Yeah, so that's how it should look like. Okay, let's move on to the next one. Okay. Now, So F, calculate the standard deviation of S. Okay, let's have a think. So the way I did this, I just used the standard deviation formula. So since we knew we had the sum of S squared and we have a sum of S, just you write down the general formula, which is the sum of S squared over N minus the mean squared, which is sum of S over N. And then you square root. Just do the simple maths over here, plug it in, you should get 1.46. Easy mark. Now here comes the last two. So Thomas uses this model to estimate the midday temperature in Cypron for a single day in October with 5 hours of sunshine. So 5 hours mean that the S value is now 5. State the value of Thomas' estimate. So this is just simply when S is 5, you plug into the equation here. So 13.1 plus 0.626 times 5, you should get 16.23 degrees. Okay, done. That's it. Now here's the last bit. So given that the values of S are all within 2 standard deviations of the mean, so in this context, within is always a plus minus interval. That's what it actually means. Comment given a reason on the reliability on this estimate. So this one's a bit weird. This seems like we're delving off statistics, but we're actually still here. So to write this, think of this carefully. So when it says within 2 standard deviations, this means plus minus 2 standard deviations, literally, of the mean. So it'd be S bar plus minus that. Now, all you have to do is simply put down the mean of S, which we know, which is sum of S over an N, plus minus 2 times standard deviation. Plug this in and then do your interval. So firstly, do the negative value to get minus 1.25 and then do the positive to get 4.59. When you get this is literally just telling you all values of hours of sunshine that it could be between. Of course, you can't have a negative, so it'll be between 0 and 4.59. And now, how can we actually relate this to this question? Well, previously it said Thomas uses 5 hours of sunshine. Since 5 is not in this interval, it's outside the interval actually, then therefore this estimate is not reliable because we're only basing models with hours of sunshine between this. Anything above, we have to extrapolate, which is another method. If it's inside, then we can estimate it. And yeah, that's really it. So hopefully all that stats talks is helping out. Otherwise, let's move on to the final question. Whew, man, I'm getting beat now. So stay with me, guys. They're almost done. Now let's do 6. So a biased coin has probability 0.4 of showing a head. So let's keep that in mind. In an experiment, the coin is spun until a head appears. If a head has not appeared after 4 spins, the coin is not spun again. So this is something to keep note here. So we're trying to see the number of times we get a head. Well, the time we get a head, then we'll stop. So the random variable x represents the number of times the coin is spun. So it can only be spun up to 4 times, okay? So we're going to have only 4 values of x. For example, x equals 3 means if the first 2 spins do not show a head, but the first spin shows a head. So what this means is that you have to keep spinning until your head is shown. So what I did here, I did like a chain of possible outcomes. So for example, if you spun a coin and you got head already, you're done. You don't spin anymore. So it'll just be probability of head, which is 0.4. If you spun a coin twice, and the first one was tails and then the second one's head, you stop there. So that'll be 2 spins and then there'll be 0.6 times 0.4 probability. And you keep on going. So the idea is that you should always get head at the end, at least for the first 4. Now, since you can only spin it 4 times, there's also a possibility you could just get all tails and no heads. So this is all the outcomes. And that's it. So this all explains the results here. So for example, again, the probability of 1 is 0.4 because it's just 1 head. To get x equals 2, so 2 variables, it'll be 0.6 times 0.4, and then same for 3. For 4, however, it'll be the sum. It'll be, because you have 2 ways of doing it. You can get 3 tails and a head on the 4th, or 4 tails and stop. And and you just sum up these probabilities. Another way you could do this is just work out these 3 and then 1 minus. Anyway, so this pretty much solves part A and B. So let's move on to C and D now. So C, find the expected value x. So the expected value is just simply this. It's just you just pick the value of x times against probability. So it'll be the product between these two and these two and these two, and you sum them up. It's very standard. So 1 times 0.4 plus 2 times 0.24 and so on. Should get 2.2 or 2.176. Now, variance x. So the variance x here is defined as the following, yeah? It's the second moment minus the mean squared. So similar to the previous questions, the second moment is simply, instead of having just the expected value x, this is the expected value of x squared. So we need to find an x squared here. So what I usually do, I just replace these x's here with 1 squared, 2 squared, 3 squared, and 4 squared, and then do the expected value. So it should be 1 squared times 0.4, like I did here, plus 2 squared times 0.24, and so on, until you get to the 4 squared times that. So resolve it, and then you should get 6.112. And finally, just plug into the general formula. So it'll be 6.112 minus the mean squared minus 2.176 squared, and you should get 1.38 variance. Oh man, explaining maths is exhausting sometimes. Now, keep it. So guys, let's move on to E. So this is the final set. So once you do this, seriously, pack up your pens and call it a day. So I just put some key info. I put the heads and tails probabilities here. We'll explain the rest of this in a sec. Okay. So the random variable h represents the number of heads obtained when the coin is spun in experiment. So explain why h can only take the values 0 and 1 and find the probability distribution of h. So this is quite clear. If you remember from the previous experiment, the whole point of this is that we're going to keep on flipping the coin until we land a head. So essentially you can only get one head. But there was also the possibility that when you get 4 tails, you get no heads. So that's why you get 0 heads or 1 head. Because you can only play until you get head, or after 4 spins you don't. So that's kind of what I wrote here. Now as for the distribution, to get 0 and 1, to get 0, as I just said, we need to get 4 tails. So just find the probability of 4 tails, which we did here, which is 0.6 times 0.6, 0.6, 0.6. And you should get this result here, 0.1296. So to get 1 is just simply, well, 1 minus that, because there's only 2 options. Yeah, that's easy. Now, F. Write down the value of this. Okay, so what does this mean? Probability x when x is 3 intersecting when h is 0. So this is telling us when x is 3, this means you get head on the third option. It's trying to say is that what is the intersection is when you get head at oh my God, I can't even say it right. When you get head at 3 or no heads. If you get no heads, then this statement doesn't make sense, because to get no heads you must have spun it 4 times and got no heads, but you actually got head already. So this is a false statement. It's mutually exclusive, so it'll be 0. Now as for this one, this is possible because if you spun it 4 times, you may possibly get head on the 4th spin, or you don't. This is asking for the time when you don't get head, and when you don't get head, this is the 4 tails assumption. So it will be the result of 4 tails, so 0.1296. So that's quite okay. Now finally, the last bit. So the random variable s equals x plus h. So just quick recap, I put the x distribution here. Now x plus h, to get s just means you're adding up these values here, like 1, 2, 3, 4 with 0 and 1. Now here we go, find the probability distribution s. Okay, so this one is we need to take our time here. So let's look at this. Let's start with h, 0 and 1. So let's assume when head is 1. So if we were to get 1 head, yeah, this means our x values would have probably been 1, 2, 3, or 4. Why? Is because to get 1 head, if we spin it once and x is 1, it means we got a head. So it'll be 1 plus 1. So it'll be 2. This means the probability of that happening is 0.4. Okay, so that's quite okay. When x, so if you get x is 2, this means you got head on the second run. So of course you got the head, h is also 1, so it'll be 2 plus 1 is 3. And the probability of that happening when x is 2 is 24, so that also goes there. Now 4 and 5 is a bit more complicated, because to get s equals 4, there's 2 options. You could either, get x equals 3, get head on the third, plus, and so that means you got h is 1, so that makes 4. Or you could do 4 spins and get 4 tails, and that way you got 0 heads. So x equals 4 and h equals 0 also gives 4. Now what I just did, I just worked out their probabilities. So when x is 3, we know when we get head on the third run, we know the probability of that happening is 0.144. However, for the 4th one, for this to occur, no heads, this means you must have got 4 tails. As usual, this result would be here, 0.1296. So therefore, to get s equals 4 is one of these, so we add them up. and that gave us 0.2736. And finally, to finish this up, instead of me calculating 5, which you can by the way, it's just when x is 4, when you get head on the fourth option, that means h is 1, so you get 5. You could do that, or you could just add all these up, 1 minus it to get that. And that's what I did. Anyway guys, I hope this video helped, and please leave me a comment, and anything else you want to talk to me, or give me any feedback for future videos like this. And otherwise, good luck with your exams, and I shall see you next time. Ciao.